KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Good morning, students. We are discussing miscellaneous exercise of relations and functions. Okay, question number 4. Find domain and range of the function f of x is equal to square root of x minus 1. Find domain and range of the function f of x equal to square root of x minus 1. But domain means what values we can give for the variable x. Okay. Range is what values function is giving by giving different values for the variable x. Okay. Now what is given function here? F of x equal to square root of x minus 1. Nothing but y is equal to square root of x minus 1. Okay. Now this function is well defined for what values of x. Suppose if I substitute in place of x 0. So what it will be? Square root of 0 minus 1, that is square root of minus 1. So square root of minus 1 is not a real number. Square root of minus 1 is not a real number, it is an imaginary number. So we cannot give x value as 0. So here whenever you have square root or fourth root, means eventh root, okay, square root of x or fourth root of x or sixth root of x, like this if we have, the inside the square root, okay, inside the square root quantity, that has to be greater than or equal to 0. Okay, then only this function is well defined. Okay, the function f of x equal to square root of x minus 1 is well defined whenever x minus 1 is greater than or equal to 0. Whenever x minus 1 is greater than or equal to 0. So inside quantity, this quantity has to be greater than or equal to 0. Okay, so x minus 1 greater than or equal to 0 means x greater than or equal to 1. So we can give x value 1 or more than 1. We can give x value 1 or more than 1. So domain of the function is what? Closed interval 1 to infinity. Closed interval 1 to infinity. Okay. Now what about range? What about range? What is the function here? F of x equal to square root of x minus 1. No? F of x is nothing but y. Y is equal to square root of x minus 1. Okay. Now here domain means x values. Range means y values. Now y is equal to square root of x minus 1. What values we are giving for x? X value is 1, 2, 3, 4 and so on. So x value is greater than or equal to 1. As x is greater than or equal to 1, x minus 1 is greater than or equal to 0. So x minus 1 is non-negative. So x minus 1 is non-negative. Square root of x minus 1 is also non-negative. So square root of x minus 1 is also greater than or equal to 0. So nothing but y greater than or equal to 0. So y greater than or equal to 0 means range value is 0 to infinity. Range value is 0 to infinity. So what values we are giving for x value? X domain. Okay, x value we are giving minimum value as 1. Suppose if we give x value as 1 here, so 1 minus 1 is how much? 0. Okay, so 1 comma 0. Graph it will be like this. Graph it will be like this. Okay, graph it will be like this. As x value increases, f of x value is also increases. Suppose x value 2. Suppose x value 2, y value is how much? 1. So 2 comma 1 somewhere here. Okay. Suppose x value is 5. Suppose x value is 5, y value is how much? Square root of 5 minus 1. Square root of 4 nothing but 2. So y is equal to 2. So what we have? 5 comma 2. Suppose x value is 10. Suppose x value is 10, y value how much? Square root of 10 minus 1. Square root of 9 nothing but 3. So what we have another point? 10 comma 3. Okay, like this. And suppose x value is 101. Suppose x value is 101. What is y value? Square root of 101 minus 1. Square root of 100. Square root of 100 is 10. So 101 comma 10. Like this we have graph. As x value increases, y value is also increases. Y value increases slowly compared to x value. So domain of the function is what? 1 comma infinity. Closed interval 1 to infinity. Range of the function is closed interval 0 to infinity. This is the graph. Okay, graph of y is equal to square root of x minus 1. Okay, so if you observe here, graph is completely lying in first quadrant. So x value cannot be negative in first quadrant. Both x and y values are positive only, no? Okay, now you have to know some basic graphs. Okay, square root of x, y is equal to x graph, y is equal to x square graph, y is equal to x cube graph. Okay, these graphs you have to know minimum. Okay, so domain of the function is for what values of x, function is well defined. Now here we cannot give x value 0 or negative values. So what is the minimum value we can give? 1. Okay, this function is square root function is defined, well defined when inside the square root is non-negative. So x minus 1 is greater than or equal to 0, x greater than or equal to 1. So domain is what? 1 to infinity. Now range, y is equal to square root of x minus 1, y is equal to square root of x minus 1. Now what values we are giving for x? 1 or more than 1. So as x greater than or equal to 1, x minus 1 is greater than or equal to 0. As x minus 1 is positive, greater than or equal to 0, square root of x minus 1 is also greater than or equal to 0. Means y greater than or equal to 0. So y greater than or equal to 0, nothing but range is greater than or equal to 0. So range of f is what? Closed interval 0 to infinity. Closed interval 0 to infinity. Next question, similar question. Find domain and range of the function f of x is equal to modulus of x minus 1. F of x is equal to modulus of x minus 1. Mod function is defined for all real numbers. Mod function is defined for all real numbers. So f of x equal to mod x minus 1 is defined for all real numbers. So domain of the function is all real numbers. Domain of the function is all real numbers, nothing but minus infinity to plus infinity, all real numbers. Okay. Next, what about range? What about range? Here modulus function is always greater than or equal to 0. Modulus function is always greater than or equal to 0. Whatever value you give for x, positive or negative, 0 or whatever it is, this quantity is always greater than or equal to 0. So y greater than or equal to 0 means range of the function is closed interval 0 to infinity. Now already we discussed mod x graph. Mod x graph will get something like this V-shaped graph, no? At 0 origin will get 0 0. Now mod x minus graph is nothing but simply shifting of mod x graph 1 unit right side. 1 unit right side. Okay. So y is equal to mod x graph, it will be like this. Okay, y is equal to mod x minus 1 graph, it will be like this. Y is equal to mod x graph, here we will have y equal to mod x plus 1 graph, shifting mod x graph 1 unit left side. Okay, so mod x plus 1, it will be something like this. So mod x minus 1 graph is like this. So what is the domain of this function? This function is defined for all real numbers. Domain is all real numbers. What about range of the function? Range of the function is whatever value you give for x. Okay, whatever value give for x, this quantity is always greater than or equal to 0. Suppose if you give x value as 1, so modulus of 1 minus 1 is 0. Okay, in remaining cases other than 1, you give whatever number that is always positive. Suppose x value minus 1. So minus 1 minus 1 minus 2, modulus of minus 2 is 2. Okay, suppose x value 2. Okay, modulus of 2 minus 1, 1, modulus of 1 is 1. So graph is like this. Okay, domain of the function is all real numbers. Range of the function is closed interval 0 to infinity. Okay, next question. Question number 6. Let f is equal to ordered pair x comma x square upon x square plus 1. Okay, f is a function contains the ordered pairs of the form x comma x square upon x square plus 1, means f of x is equal to x square upon x square plus 1. But this is domain value, this is range value. Okay, So how function is defined? F of x is equal to x square upon x square plus 1. Okay, let f of x is equal to ordered pair x comma x square plus 1, means f of x is equal to x square upon x square plus 1 be a function from R to R, means domain and codomain both are real numbers. We have to find the range of R. Find range of R. Okay, but here y is equal to f of x is equal to x square upon x square plus 1. This function is defined for all real numbers. Domain is R, anyhow that is given, domain is all real numbers. Okay, now if you observe y is equal to what? X square upon x square plus 1. Y is equal to x square upon x square plus 1. X square is always greater than or equal to 0. X square is always greater than or equal to 0. 1 plus x square is always greater than or equal to 1. So numerator positive or 0, denominator is always positive. So positive upon positive is greater than or equal to 0. Okay, so y value range is always greater than or equal to 0 for every real number. Suppose x is 0, in such case y is 0. Other than x is 0, okay, other than x is 0, okay, other than 0, you take any real number, this is always positive. Ratio is always positive. So y is always greater than or equal to 0 for every real number. For every real number. Now one more thing, y greater than or equal to 0, that part we know. Okay. What about maximum value? What about maximum value? If you observe here, when numerator is positive, denominator is also positive, but numerator is 1 less than the denominator. Numerator is 1 less than the denominator. Suppose numerator is 99, denominator is 100. Okay. Suppose numerator is 999, denominator is 1000. So numerator is 1 less than the denominator. So the ratio always less than 1. Ratio is always less than 1. That is what it is written here. 1 plus x square is always greater than x square. So x square upon 1 plus x square is always less than 1. 1 is greater than x square upon 1 plus x square. Nothing but y. So y value less than 1. Also y value greater than or equal to 0. So y ranges from closed interval 0 to open interval 1. So range of the function is 0 included, 1 excluded. Okay, 0 included, 1 excluded. Okay, as x approaches to infinity, okay, this is very big number, but denominator is 1 more than the numerator. So obviously that ratio is less than 1. Okay. So domain is all real numbers, range wise, because numerator greater than or equal to 0, denominator positive, so ratio is always greater than or equal to 0. Ratio is always greater than or equal to 0. So range is always greater than or equal to 0. But numerator is 1 less than the denominator, this ratio obviously less than 1. Okay, numerator positive, denominator positive, okay, but numerator is 1 less than the denominator, this ratio is less than 1. So y value less than 1. So y greater than or equal to 0, y less than 1. So range of the function is closed interval 0 to open interval 1. Okay, next question. Let f and g be two functions defined from R to R. How it is defined? F of x is equal to x plus 1 and g of x is equal to 2x minus 3. F of x is defined as x plus 1 and g of x is defined as 2x minus 3. How to find f plus g, f minus g and f by g. Now f plus g is nothing but f of x plus g of x. F plus g of x is nothing but f of x plus g of x. What is f of x? X plus 1. What is g of x? 2x minus 3. Now f of x plus g of x nothing but x plus 1 plus 2x minus 3. How much total? 3x minus 2. That is f plus g. Next f minus g. F minus g is f of x minus g of x. What is f of x? X plus 1. Okay. What is g of x? 2x minus 3. Minus of g of x is minus 2x plus 3. So what we have? X minus 2x minus x, 1 plus 3, 4. 4 minus x. F of x minus g of x is 4 minus x. Next f by g. F by g is nothing but f of x upon g of x, where f of x is x plus 1, g of x is 2x minus 3. Okay, but the denominator should not be 0. Denominator should not be 0. But this rational function is defined whenever denominator is non-zero. Denominator is 0 at what value of x? At x is equal to 3 by 2, denominator is 0. So other than 3 by 2, it is well defined. So f of x upon g of x is x plus 1 upon 2x minus 3, where x is any real number other than 3 by 2. X is not equal to 3 by 2. Okay, next question. My 8th question I skipped because 8th question is one of miscellaneous example problems. Okay, next 9th question. Let R be a relation from n to n defined by, how it is defined, relation R is ordered pair a comma b, both a and b are natural numbers and a is equal to b square. My relation between first element and second element is what? First element is square of second element. Okay, first element is square of second element. Okay, my relation is defined as ordered pair a comma b, where a and b are natural numbers and first element is square of second element. Okay, relation from n to n, natural numbers to natural numbers, defined by R is equal to ordered pair a comma b, where a and b are real number, a and b are natural numbers, and relationship between a and b is first element is square of second element. Okay, now you have to check whether the following are true or not. Okay, following conditions are true or not. Okay, a comma a belongs to R means 1 comma 1 belongs to R, 2 comma 2 belongs to R, 3 comma 3 belongs to R, 4 comma 4 belongs to R. Okay, a comma a belongs to R for every natural number, for every natural number. Okay, one by one we'll check. First one, a comma a belongs to R for every natural number. This statement is true or false, you have to check. Okay, here a comma a belongs to R for every natural number, it is a false statement, because now what is relation between first element and second element? First element is square of second element, no? Means a is equal to a square. A is equal to a square, both a and b. A is a natural number. So this given statement a equal to a square is true only when a is equal to 1. Suppose a is equal to 1, 1 is equal to 1 square, no? 1 is equal to 1 square. But if we consider 2 is equal to 2 square, 2 is not equal to 2 square, no? So this given condition a comma a belongs to R, this is true only for a is equal to 1, not for other natural numbers. So what is the relation given? A is equal to b square. First element is square of second element. Now a comma a belongs to R, what is it meaning? First element a is equal to square of second element. Okay, now left hand side and right hand side equal when a is equal to 1 only, for a is equal to 1 only, not for other natural numbers. Suppose if you consider 2 comma 2, 2 comma 2 belongs to R, it's not belongs to R, because 2 is not equal to 2 square, no? So 2 comma 2 does not belongs to R, 3 comma 3 does not belongs to R, 4 comma 4 does not belongs to R. So a comma a belongs to R, this statement is true only for a is equal to 1, not for other natural numbers. But given for every natural number, this has to true for every natural number. So this is not true for every natural number. So obviously the given statement is false statement. Given statement is false statement. Okay. Second one. What is given second statement? A comma b belongs to R. Okay, ordered pair a comma b belongs to R implies that ordered pair b comma a belongs to R. Suppose a comma b is an ordered pair in the relation, then its reverse, b comma a, ordered pair b comma a is also belongs to R. That given statement is true or false, that we have to check. Okay, I'll prove this one with an example. Now you can observe here 9 comma 3 belongs to R, no? 9 comma 3 belongs to R, because first of all 9 and 3 both are natural numbers. Moreover, first element is square of second element. Okay, 9 is equal to 3 square. Okay, so it can be seen that 9 comma 3 belongs to R, because 9 and 3 both are natural numbers. Also first element 9 is square of second element. So here 9 comma 3 belongs to R, but 3 comma 9 does not belongs to R, because here first element is not the square of second element, no? 3 is not equal to 9 square. 3 is not equal to 9 square. So here 9 comma 3 belongs to R, but 3 comma 9 does not belongs to R. So the given statement a comma b belongs to R, ordered pair a comma b belongs to R, implies that ordered pair b comma a belongs to R. This is a this is not a true statement. This is not a true statement. Okay. So what is given is if A comma B belongs to R, ordered pair A comma B belongs to R, implies that ordered pair B comma A belongs to R. Okay. So to prove this, okay, I will consider 9 comma 3 belongs to R. Okay, ordered pair 9 comma 3 belongs to R because 9 and 3 are natural numbers. Also first element 9 is square of second element 3. Okay. Next, but 3 comma 9 does not belongs to R because 3 is not square of 9. 9 comma 3 belongs to R, but 3 comma 9 does not belong to R. So the given statement A comma B belongs to R implies that B comma A belongs to R is not a true statement. Okay. Next, third one, if A comma B belongs to R and B comma C belongs to R, then we have to check whether A comma C belongs to R. Okay. If A comma B belongs to R and B comma C belongs to R, implies that A comma C belongs to R. Okay. So here A comma B belongs to R. A comma B belongs to R means A is square of second element, nothing but A is equal to B square. Now B comma C belongs to relation means B is square of second element, so B is equal to C square. Now here A is equal to B square, B is equal to C square, A is equal to B square. In place of B what we can write? C square. A is equal to C square whole square. So A is equal to C power 4. Okay, A is equal to C power 4. A is equal to C power 4 means A is not equal to C square, no? A is not equal to C square. So A is not equal to C square means A comma C does not belongs to R. As A not equal to C square, A comma C does not belongs to R. Ordered pair A comma C does not belongs to R. So the given statement ordered pair A comma B belongs to R and ordered pair B comma C belongs to R implies that ordered pair A comma C belongs to R is not a true statement. Not a true statement. Now what is given here? If ordered pair A comma B belongs to R and B comma C belongs to R, okay, ordered pair A comma C belongs to R or not, that we have to check, true or not. Okay, ordered pair A comma B belongs to R means according to the relation, first element is square of second element, so A is equal to square of B. Okay, ordered pair B comma C belongs to R means first element B is equal to square of second element C, so B is equal to C square. So from these two what we can write? A is equal to B square, but B is what? C square whole square, so A is equal to C power 4. As A is equal to C power 4, A is not equal to C square, no? So A is not equal to C square means A comma C, ordered pair A comma C does not belongs to R. So the given statement A comma B belongs to R and B comma C belongs to R implies A comma C, ordered pair A comma C belongs to R is not a true statement. Okay. Next question. My next question, question number 10. Let A is equal to, set A is equal to 1, 2, 3, 4. Set B is equal to 1, 5, 9, 11, 16. Okay. Now here a relation given F is equal to ordered pair 1, 5, ordered pair 2, 9, ordered pair 3, 1, ordered pair 4, 5 and ordered pair 5, 11. Okay. Now two statements are given, whether these are true statements or not we have to verify. Are the following are true? First statement is F is a relation from A to B. F is a relation from A to B. Second is F is a function from A to B. Now what is given? A is a set containing elements 1, 2, 3, 4, B is a set containing elements 1, 5, 9, 11, 16 and F is given as ordered pair 1, 5, 2, 9, ordered pair 3, 1, ordered pair 4, 5, ordered pair 2, 11. Obviously F is subset of a Cartesian product A cross B. F is a subset of a Cartesian product A cross B. Any subset of Cartesian product is a relation. Any subset of Cartesian product is a relation. F is a subset of A cross B, hence F is a relation from A to B. Okay. Now if you observe this relation, we can write like this: 1, 2, 3, 4 here, 1, 5, 9, 11, 16. 1 is mapped to 5, 2 is mapped to 9, 3 is mapped to 1, 4 is mapped to 5 and 2 is mapped to 11. Now if you observe in these ordered pairs, we have two ordered pairs. One is ordered pair 2, 9, ordered pair 2, 11. For these two ordered pairs, ordered pair 2, 9 and ordered pair 2, 11, for these two ordered pairs, first element is same. What is the first element for these two ordered pairs? 2. Okay, the ordered pairs 2 comma 9 and 2 comma 11 have same first component, so it is not a function. My relation is a function if every element of domain is mapped to exactly one element in codomain. Okay, but here the element 2 in the domain is mapped to more than one element. 2 is mapped to 9, 2 is mapped to 11. So this relation is not a function. This is a relation, but it is not a function. Why it is a relation? Because it is a subset of Cartesian product A and B. So obviously it is a relation. It is not a function because one element in the domain is mapped to more than one element in codomain. 2 is mapped to 9 and 2 is mapped to 11. So this relation is not a function. Okay, next question. F be a subset of Z cross Z, okay, where Z is integer set defined by F is equal to ordered pair AB comma A plus B, where A and B are integers. Now here you have ordered pairs, product of A and B comma sum of A and B. Okay, whether F is a function from Z to Z, justify your answer. Now this is a function or not. Okay, now if I consider A0 B1, A0 B1, so first element is what? Product 0, second element is what? Sum 0 plus 1 1. So 0 comma 1, ordered pair 0 comma 1 belongs to F. Okay, now if we consider A0 B2, A0 B2, then first element is what? First component is product of these two 0, second component is sum of these two, that is 2. 0 comma 2 belongs to F. Now 0 comma 1 belongs to F, 0 comma 2 belongs to F, means 0 in the domain is mapped to 1 and 2. Not only this, you can give one more example. A0 B3, then first component is what? Product 0, second component is 0 plus 3 3, 0 comma 3 also belongs to F. So 0 map to 1, 0 map to 2, 0 map to 3, 0 map to 4. Okay, so you have ordered pairs 0 1, 0 2, 0 3 having same first component. So obviously it is not a function. It is not a function. So this is not a, F is not a function. Next question. Set A is containing the elements 9, 10, 11, 12, 13. F is a relation from A to N, where N is a natural number set. How it is defined? F of N is equal to highest prime factor of N. Highest prime factor of N. Okay, highest prime factor of N. So we have to find the range of F. Okay, now here how it is defined? F from A to N by F of N is equal to highest prime factor of N. Now for N is equal to 9, how we can write? 9 is equal to 1 into 3 into 3. Now what is the highest prime factor here? 3. So F of 9 is equal to how much? 3. Next 10 what we can write? 10 we can write as 2 into 5, where 2 and 5 both are prime numbers. What is the highest prime factor here? 5. Okay, highest prime factor of 10 is what? 5. So F of 10 is equal to 5. So 11 what we can write? 11 itself is a prime number. So 11 we can write as 1 into 11. So highest prime factor of 11 is 11 itself. So F of 11 is equal to 11. For N equal to 12. So 12 what we can write? Prime factorization 1 into 2 into 2 into 3. Now what is the highest prime factor here? 3. So highest prime factor of 12 is 3. F of 12 is equal to how much? 3. For N is equal to 13. 13 itself is a prime number. So prime factor of 13 is what? 13 is equal to 1 into 13. So highest prime factor is 13. So F of 13 is equal to 13. Okay. So F contains the ordered pairs. Ordered pair 9 comma 3, 10 comma 5, 11 comma 11, 12 comma 3 and 13 comma 13. Now range means collection of second components in ordered pairs. So what are the second components? 3, 5, 11, 3, 13. Nothing but range of F is 3, 5, 11 and 13. Okay. But here question A is given as set containing the elements 9, 10, 11, 12, 13. Okay, F is a function from F is from A to N defined by F of N is equal to highest prime factor of N. Range of F we have to find. Okay, so highest prime factor of each number. So 9 highest prime factor is 3, Okay, 10 highest prime factor is 5, 11 highest prime factor is 11, 12 highest prime factor is 3, 13 highest prime factor is 13. So F contains the ordered pairs 9 comma 3, 10 comma 5, ordered pair 11 comma 11, ordered pair 12 comma 3 and ordered pair 13 comma 13. So range of F is what? Second components. Okay, now 3, 5, 11, 13. So range of F is 3, 5, 11 and 13. Okay, now with this we completed relations and functions topic. Okay, next class will start trigonometry.